Alright guys, so this is the video for chapter 12, which is matrices. And in this chapter, we're not going to go into a lot of depth. We're just going to get the generalized and the basic stuff. But do know that, like when you get into college, there's an entire semester class called linear algebra that solves every kind of math problem you can imagine with just matrices. So this is just one more way to solve problems and figure stuff out. All right, so before we get started, let's get into a little bit of vocabulary here. Okay, so let's first define matrix. So a matrix is simply a rectangular array of numbers. It's a different way of representing an equation or different things, as we'll see. So the dimensions of a matrix with m rows and n columns, we call it an m by n matrix. Okay, so the rows are this and this, okay, and then the columns are this, this, and this. So rows are left and right, and columns is up and down. So we would call this here, since there are 2 rows and 3 columns, we would call it a 2 by 3 matrix. All right, so the numbers in the matrix, so in here you can see 1, 2, 3, 4, 5, 6 numbers. These are all called elements. Okay, so like we would say, this is the element in row 1, column 1. Okay, this is the element in row 1, column 3, and so on and so forth. But each one of these are seen as an individual, and they are all called elements. Two matrices are equal when their dimensions are the same, okay, and so both of these have to happen, and the elements in the corresponding positions are equal. All right, so the first operation we're going to do is we're going to learn how to add and subtract matrices. Okay, so the first thing that we need to know is to add or subtract two matrices, we add or subtract their corresponding elements. And this will make more sense once we do an example or two. Okay, but it is important to note that we can add and subtract matrices only when they have the same dimensions. Okay, so you could not subtract like a 3 by 2 matrix plus, or a 3 by 2 matrix minus a 2 by 3, or a 4 by 1 plus an 8 by 6. Okay, we can't do that. They have to have the same dimensions. Okay, so notice here, okay, we would add the elements in the same corresponding position. So A and C are in the same corresponding position. So when we add these two matrices, the same corresponding position in the matrix where we sum them is just A plus C. Okay, same thing with B and F. They're in the same. So when we add them, we'll just add B plus F. C and G, we'd add them, C plus G. And then D plus H, and then when we add them, it's just D plus H. Okay, and then the same applies when we subtract, except we're going to subtract instead of add. And like I said, this will make much more sense once we do an example. Okay, so let's look at example 1 now. Okay, it says perform the indicated operation if possible, if not, explain why. Okay, so notice we want to add these two matrices. Okay, so the first thing we need to do is we need to figure out, do they have the same dimensions? Okay, well, this one has 1, 2 rows and 1, 2 columns. So we would say this is a 2 by 2 matrix. Okay, and then the same thing here. This has 1, 2 rows and 1, 2 columns. So this is also a 2 by 2 matrix. And because they have the same dimensions, then we can in fact add them. Okay, so when we add them, we're just going to get another matrix. Okay, so the first thing we do is we're going to add row 1, column 1 element of each. So we would just have 2 plus 1. Okay, and then how about first row, column 2 is negative 1 and 2. So we would say negative 1 plus 2. Let's do row 2, column 1 is 3 and 4. So to get that element, would do 3 plus 4. And then last but not least, we have the second row, second column, 0 and -2. So I would just do 0 plus -2. Okay, now we just need to clean it up. Okay, 2 plus 1 is 3. -1 plus 2 is +1. 3 plus 4 is 7. And 0 plus a -2 is a -2. So this is my final answer. So notice when we add two 2x2 matrices, we get a 2x2 matrix. That should always be the case. All right, so let's look at example B. Okay, so here we're going to subtract these two matrices. So it's the same process, we're just going to find the difference. Okay, so the first thing we need to do is we need to check the dimensions. Okay, so we have a 1, 2, 3 rows by 1, 2 columns. So we would say this is a 3x2 matrix. And then over here we have 1, 2, 3 rows by 1, 2 columns. So we would say this is also a 3x2 matrix. Okay, now because these two matrices have the same dimensions, we can in fact subtract them. And when we subtract them, we're going to get another 3x2 matrix. Okay, so we have in the same corresponding positions the 2 and a -1. So over here, I would have 2 minus a -1. And once again, we're subtracting. Okay, so the next one in the corresponding positions, -3 and 2. So I could write -3 minus a 2. Okay, then our next position, we have a 5 and a 7. So I would subtract 5 minus 7. And then I have a 4 and an 8. And so I would subtract 4 minus 8. Okay, and then the last row, I have a -2 and a -5. So a -2 minus a -5. And then last but not least, I have an 8 and a 6. So I would have an 8 minus 6. Okay, now if I clean this up, okay, 2 minus a -1 is simply 2 plus 1, which is 3. -3 minus 2 is a -5. 5 minus 7 is a -2. 4 minus 8 is a -4. 2 minus a -5 is a 2 plus 5, which is a +3. And then 8 minus 6, which is 2. So the difference of these two matrices would be this 3x2 matrix right here. All right, so let's look at C now. Okay, so we're going to add these two matrices. So the first thing you're going to do is make sure that our dimensions are the same. Okay, so this is 1, 2 rows by 1, 2, 3 columns. So that would be a 2x3 matrix. Okay, and then over here I have 1, 2 rows and 1, 2 columns. So this is a 2x2 matrix. Okay, well, as you can see, the number of columns in the first is different than the number of columns in the second. So because these dimensions are not exactly the same, I would just say cannot add. And the reason is because they have different dimensions. All right, if we go on in our notes, okay, we have this clause that talks a little bit about scalar multiplication or scalars. So in operations with matrices, numbers are referred to as scalars. Okay, this gets a little more technical when you get into linear algebra. But for now, at this point, just think of scalars as a number. Okay, not in a matrix, it's just a number. Okay, so to multiply a matrix by a scalar, we multiply each element by the scalar. Okay, and when we do this, the product is called scalar multiplication. Okay, we can think kind of it like the distributive property a little bit. Okay, so if I look down here as an example, we have a 2x2 matrix. Okay, and this here, this K here, it's going to be a number. This is my scalar. Okay, so when I multiply this, think of the distributive property. I'm going to distribute this K into each one of this elements. Okay, so my ABCD matrix would become KA, KB, KC, and KD matrix. And this will make more sense when we do an example. All right, so if I look at A, okay, notice I have a 3 by 2 matrix, and then I have a scalar right here, and my scalar is a 2. Okay, so I'm going to put my scalar, I'm going to distribute it to each one of the elements. And I get some of you don't have to write this all out, but I'm going to go ahead and write it out just for those of you that need it. Okay, so what my new matrix would be, it'd be 2 times 3. And I got that 3 from right here, the 2 from right here. Okay, if I work down, this would be 2 times 1, and this would be 2 times 2. Okay, if I go to my second column, I have a 2 times negative 2. I have a 2 times 5, and I have a 2 times 0. Okay, and when I clean this all up, I get a 6, 2, 4. 2 times negative 2 is negative 4. 2 times 5 is 10, and 0. And this here is my final answer. Okay, so if I look at example 2, part B, okay, notice I have a scalar here, but not one over there. Okay, and then I have an addition. I'm going to add these two matrices. So just like order of operations in algebra, I'm going to go ahead and apply my scalar first. Think of this as a distributive property. Okay, and then I'm going to use that new matrix to add to -1, 7, 3, and 2. Okay, so the first thing I'm going to do is I'm going to multiply my scalar through. So 5, 0, -2, and 4. Oops. So when I do that, I get -3 times 5. I get -3 times a -2. I get a -3 times 0, and a -3 times 4. Okay, and if I clean that up, this is -15. -3 times -2 is a 6. -3 times 0 is a 0, and -3 times 4 is a -12. And there's my new 2 by 2 matrix. Okay, so now this cleaned up is this. Okay, so now I'm going to go ahead and add them. So I'm going to take this new matrix with the scalar in it. So 6, -12. And then I'm going to add it to my -1, 7, 3, and 2. Okay, so once again, I'm just going to add each element in corresponding positions. So this is -15 plus a -1. This is a 6 plus 3. This is a 0 plus 7. And a -12 plus 2. Okay, and if I clean that up, -5 plus a -1 is a -6. 6 plus 3 is 9. 0 plus 7 is 7. -12 plus 2 is a -10. And here is my final matrix. All right, guys, I did just notice my -15 turned to a -5. So this should be a -15, and this should be a -16. And this should be my corrected matrix.